Welcome to Mr. Wyatt's recording studio, and today we're going to talk about problem number 44, page 688, sound location using hyperbolas. So this problem tells us that we have two listening stations, one at 3300 0 and another at minus 3300 0 and a third listening station at 3300 and 1100. Okay, so from example 5, we know that the microphones are the foci of a hyperbola, and let's call this listening station A, this one B, and the third one we'll call C. Now, we know that these microphones are at the foci of the hyperbola, so that says that this distance between those two is 6,600 feet. It's also 2c in terms of hyperbolas. So that's 2c is equal to 6,600. So C is equal to 3,300. So we have the first piece of information about our hyperbola. Now we also know that sound arrives at B 4 seconds later than at A. So that means the difference in distance between A and B is 4,400 feet. If we draw a hyperbola just somewhere here, then we know that this distance here is C minus A, because it's A from here at the center to the vertex, it's C to the focus, so the distance between the vertex and the focus must be C minus A. Now, we also know that this distance from the other focus to this vertex is C from the focus to the center, and then A from the center to that vertex. So this entire distance is C plus A. So now then, we know that the difference between those two distances, C plus A minus C minus A, that difference is 4,400, right? Because it took 4 seconds, 4,400 feet, for the sound to arrive at B after it arrived at A. So C plus A minus C plus A is 2A is equal to 4,400. So now we have another piece of information about our hyperbola. So we can continue to work on solving this hyperbola. We have x squared over a squared minus y squared over b squared is equal to 1. We know that A is 2,200 because we just solved for that. 2A is 4,400, so A is 2,200. We also know that C squared is equal to A squared plus B squared. So C squared is 3,300 squared minus 2,200 squared, which is A, is equal to B squared. So when we do that calculation, we find that B squared is equal to 6,050,000, and that's B squared. So now we have an equation for our hyperbola, x squared over 2,200 squared minus y squared over 6,050,000 is equal to 1. So there's our first hyperbola that shows this direction. The sound has to lie somewhere on that hyperbola. But now then, we've got the relationship between A and C to use to try to solve for where is the actual location. So let's make a hyperbola out of that using the same approach. So we know that 2C is equal to 1100 because that's the difference in distance between the microphones. So C is 550. We also know that the difference in distance calculated by the sound is 2A is equal to 1100. So A is 550. So over here on our sketch of the hyperbola, we have this, and that says that's C, and that's also 2A. Well, let's calculate B. C squared is equal to A squared plus B squared. Well, 550 squared is equal to 550 squared plus B squared. B squared is equal to 0. Well, what that says is that this hyperbola has no width, that the asymptote is a vertical line, which means that this hyperbola is actually just a vertical line. Instead of looking like a hyperbola, it's just a line. Well, now then, we can go back and find the intersection of the original hyperbola that we found and this line. If we find that point, we know where the sound comes from. Because the sound arrives at C after it arrives at A, that must mean the sound happened down here, traveling upward on our picture. So we can just set those two equations equal to each other. We can do x squared minus y squared over 2200 divided by 66,050,000 is equal to 1, and the intersection with the line x is equal to 3300, which is the same as plugging in 3300 for x and solving for y. So we can do 3300 squared over 2200 squared minus y squared over 6050000 is equal to 1, which gives us y squared is equal to the square root of 3300 squared over 2200 squared minus 1, that entire quantity times 605000, and it turns out that y is minus 2750. So this point has the coordinates 3300 minus 2750, and that's the location of the explosion that we were looking for with this hyperbola.